everyone, and welcome to episode 2 of Net Ionic Equations. Today we're going to do a couple more reactions and then we'll write the net ionic equations for them using the same steps that we outlined in episode 1. First up, we'll see what happens when we mix some potassium chlorate with some iron 2 sulfate. Both of these compounds are soluble in water, so just give me a second to get these dissolved. Here we have our potassium chlorate, and in goes the iron 2 sulfate solution, and nothing happened. So did I just mess things up right now? Well, no. And it goes like this. We know the potassium chlorate is soluble. Any good solubility table will tell you that, and we can see it dissolved. Iron 2 sulfate is also soluble. When I mix them, I have two possible products, iron 2 chlorate and potassium sulfate. Both of those are also soluble. Since both of the two possible products are soluble, then nothing happens because they all just stay soluble and floating around in the solution. If you're watching this video, the odds are pretty good that you'll be working your way along predicting the products of reactions, and you'll come across something where there is no reaction. For example, in this case, this double replacement reaction, if I were to predict the products, iron 2 chlorate and potassium sulfate. Note that I did balance the charges over here. Iron is +2, this is -1, and so on. So those are the formulas that I get. But if I check my solubility chart, I find out that this is soluble, as well as this. This is also soluble. That, in combination with the two soluble reactants, means that everything here is soluble, and what you should just write, once you figure this out, is just write no reaction. Simply mixing two chemicals together does not guarantee that a reaction is going to happen. In this case, something has to be insoluble, and nothing was insoluble, so nothing happened. And now for another attempt, which I hope will be a little more exciting. I have some silver nitrate, which I'm going to mix with some potassium chromate. Both of these are also soluble, so again, give me a second to make our solutions. So now I've got everything dissolved. The silver nitrate is over here in a nice clear solution, and the potassium chromate is here, and it gives it a nice yellow color because of the chromate ion in solution. Let's see what happens up close when I mix these. In goes the silver nitrate, and oh, wow, look at that. Nothing like a good rusty colored precipitate to improve your day. So just like last time, our job is to try to decide what that is and what is the net ionic equation for the reaction that occurred. First, let's start with the complete chemical equation, which we get when we swap the cations from one to the other. And we'll get Ag2CrO4 and potassium nitrate, which is just KNO3. At this point, we have to stop and look at our solubility tables to decide which of those two possible products is the red precipitate, right there. And it can't be the potassium nitrate because potassium and nitrate are both always soluble, and so they can't be insoluble together. That leaves silver chromate as our solid precipitate. So we'll go ahead and put a little S right there, and we'll keep an AQ over there. For the complete ionic equation, we're just going to break apart everything that's aqueous, this, and that. So we'll go down here and we'll add silver, some nitrate, 2 potassium ions, because there's 2 there, and a chromate ion. We're going to keep the silver chromate together because it actually is together now. They found each other in the beaker and fell in love, and now they've formed a strong chemical bond that water cannot dissociate. And okay, and the NO3 are going here. Once again, I completely forgot to balance the equation at the start by putting a couple of 2's there, which means that we're going to need a 2 there, and a 2 there, and a 2 there, and a 2 there. And finally, to get to our net ionic equation, we are going to cancel out and get rid of the loser ions that did not pair up with anybody. That includes nitrate, which starts by itself and ends by itself, and potassium, which starts by itself and ends by itself. That makes our net ionic equation 2 Ags, keep that 2 along with the Ag, plus the chromate, makes silver chromate. And as always, put a heart next to it. Once again, a friendly reminder to put charges on ions that are soluble in aqueous solution, and also balance the charges when you create the new compound on the right-hand side. And now it's your turn to practice your predicting skills and write a net ionic equation. I have here some iron 2 sulfate that I used in my first example, and I have here some barium nitrate. I'm going to go ahead and dissolve these while you pause the video and see if you can predict the products and the net ionic equation. Correct. If you were able to predict that something will happen in this reaction and that a precipitate will form, then congratulations, you're doing a very good job. We'll check the equations in a minute, but let's see the reaction first. Once again, up close and personal, let's see what happens when the barium nitrate goes in with the iron 2 sulfate. There we go. So your equation should look something like this, minus the errors over here that we'll just try to ignore those. Nitrate and sulfate, they're like the same thing, right? They're not? Sulfate is soluble, barium nitrate is soluble. The barium sulfate is our insoluble precipitate, and the iron 2 nitrate is again still soluble. So the iron and nitrate are my loser ions, so we'll cross those off. And we're left with sulfate, which is a 2- charge, sorry about that, and barium making barium sulfate. And in this case, barium is written first, even though it's not over here, because barium is the metal, it's the cation, and it should go first. So there you have it. 2 more colorful reactions with net ionic equations to go with them. Thanks for watching, and happy equation balancing.